This is Unit 8, Chemical Bonding, Part 2 Notes. By the end of this unit, you should be able to express the arrangement of electrons and atoms through Lewis valence electron dot structures for both ionic and covalent compounds. So just to review, Lewis dot structures of neutral atoms, those represent the valence electrons in simple form. The dots are identified by the group number, so you have to use the periodic table to identify the number of valence electrons. Only one dot can be added per side at a time, and then you have to reform the pairs when all the sides are originally filled. Don't forget the happy number is 8, and you think of these elements as being within a box. So you have to add one dot per side before you can go back up and pair them. So aluminum is in group number 3, so it's going to have 3 dots. 1, 2, 3 electrons. Chlorine is in group number 7 or 17 or 7A, so we add 1 dot per side. 3, 4, 5, 6, 7. So it's very rough dots, but you should have 7 total electrons around the chlorine. Lewis dot structures follow this octet rule. So again, the happy number is 8. You gain or lose electrons to have elements fill their valence shell. Hydrogen and helium are the exception because they only have 2 electrons because they're on the first ring or the first row of the periodic table, so they can only have a maximum of 2, and that is the 1s orbital, and that's where the 2 electrons come from. So whenever elements form ions, you either show the Lewis dot structure by gaining or losing electrons. So cations are going to lose electrons to form positive charges. So like sodium is in group number 1, so it should have 1 valence electron. But group 1 elements always form a +1 charge, so you erase that electron and you notate its charge in the upper right-hand corner. Sulfur is in group 16 or 6A, so you're originally going to have 1, 2, 3, 4, 5, 6 electrons. Those lines are actually dots. They form -2 charges because they're going to gain those last 2 electrons to have a full valence shell. So cations are going to lose electrons and they form positive charges. Anions should have a total of 8 electrons, and they're going to form those negative charges. So to show the formation of ionic bonds between 2 or more elements, they form bonds by electron transferring. Hence your ionic compounds, you have a cation and you have an anion. So for example, if we're trying to show the formation of sodium chloride, sodium is Na, and it's in group number 1, so it's going to have 1 valence electron. Chlorine is in group 7, so it's going to have 7 valence electrons. Just to review the formula, Na is +1, Cl is -1. So when you cross and drop your charges, we get Na1Cl1. So to show the formation of NaCl, we show 1 sodium atom combining with 1 chlorine atom. Sodium's a group 1, they form a +1 charge because they lose this 1 valence electron and they transfer it to the chlorine atom. So whenever they form that bond, they're going to share, well, they don't share electrons. The electrons are transferred, so the attraction between the positive and the negative, that's where that attraction occurs between those opposite charges. So then to show the formation, you have sodium that lost all of its electrons combined with the chlorine that's gained all of the electrons. Then you need to specify the charges in the upper right-hand corner. So again, sodium just transfers its 1 electron to the chlorine atom. And then you show that by identifying them with the charges. So if you were to draw the Lewis dot structure for the following compounds, again, KBr, this is potassium bromide. You have a K +1, and then you have a Br -1, cross and drop, and you get the substrates 1 and 1. Potassium, group number 1, so it's going to have 1 dot, or 1 valence electron. Bromine is in group number 7, 5, 6, 7. So then you show the formation of this ionic bond by transferring this 1 single electron to the bromine atom. So you'll have the bond formation, and then you need to include 2, 3, 4, 5, 6, 7, include all of the electrons. So we need to specify the anion by being within brackets because the electrons are all surrounding the bromine. The potassium ion has no electrons surrounding its structure. So this picture to the right, that is the ionic Lewis dot structure of potassium bromide. And I'm going to erase it, so if you need to write it down, press the pause button. But I want to do the MgCl2, and I'm going to need a little bit more space because magnesium chloride, Magnesium is a +2. Ooh, that's really large. I'm sorry. Ooh, where's my eraser? Magnesium is a +2 charge. Chlorine's a -1 charge. So when you cross and drop the 2 and the 1, that's where you get the MgCl2. So your magnesium is in group number 2. So it's going to need 2 dots around its structure. And I'm going to show it on the opposite sides because I know I'm going to have 2 chlorine atoms come in where each one is going to have 7. 2, 3, 4, 5, 6, 7. And I'm following the rules, but I'm shorthanding the pairing back up rule. Okay, so I guess I can do them in red. You have 1 single electron and 1 single electron. So chlorine has 7 total around each of those atoms, and magnesium is in group number 2, so it's going to form that +2 charge. Well, how does it form that +2 charge? Well, it loses 2 electrons. So it's going to donate each of its valence electrons to the chlorine atoms, and they're going to form the compound magnesium chloride. So you need to press pause, write this intermediate step down, and I'm going to erase it and finish off by writing the final formula, where you have to specify the electrons around your anion. So what we're going to have is Mg with a 2+, and then within brackets, you're going to have the Cl with the electrons. Let me make this a little bit bigger. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So everything should have 8. So magnesium lost its 2 electrons and allowed chlorine to gain them. Then you also need to specify those charges in the upper right-hand corner where magnesium has a 2+ charge and both chlorine atoms have a negative charge. So for ionic compounds, we need to show the formation of those ionic bonds by showing the electron transfer using arrows. Covalent Lewis dot structures are a little bit different because the covalent bonds are now going to be formed through sharing of electrons, so there's no electron transfer between those 2 or more atoms. And we need to represent the bonds that they're being shared by drawing lines. And each line is going to represent a single bond that holds 2 electrons. So to draw the covalent compounds, you have to first calculate the total number of electrons needed for each molecule. And you do that by looking at the formula. Okay? So there's bromine. Bromine's in group number 7, so there's going to be at least 7 valence electrons, but there's 2 of them, so I'm going to need a total of 14 electrons. Oxygen is in group number 6, so it has 6 valence electrons. There's 2 oxygen atoms, so I'm going to need a total of 12 electrons. Nitrogen is in group 5A, so you have 5 valence electrons, and there's 2 of them, so I'm going to need a total of 10 electrons. And that's step number 1, by calculating the total number of electrons. So you just look at the formula. You need to identify the central atom. If there are 3 or more elements, not different types of elements, just elements in general. If there's 3 different atoms, then you need to identify the central one. And that's usually going to be the least electronegative element. There are some exceptions to that rule, but most of the time, if you identify the least electronegative, it's going to be the central atom. And then we have to make sure we abide by all octet and duet rules. So every element besides hydrogen and helium are going to need 8 electrons around its structure. So if we're going to do bromine, bromine's a naturally existing diatomic molecule. In fact, bromine, oxygen, and nitrogen are your naturally occurring diatomic molecules. Just to review that, we have H2, N2, O2, F2, Cl2, Br2, I2. All of these 7 elements are naturally existing diatomic molecules. Well, bromine has 14 electrons within its structure, and so we have to make sure all atoms are abiding by the octet rule. So each of those bonds are being shared because it's covalent. Covalent's 2 or more nonmetals. Since each line represents 2 electrons, I have a total of 8 around this bromine, and then I have a total of 8 around the other bromine. So for oxygen, it's a little bit different because we had 6 around each oxygen atom, but then we had to move electrons to be able to allow the sharing of that double bond between the oxygens, because then that allows them to both have 8 electrons. So if each line is 2 electrons, this is 4, plus those 2 is 6, plus those 2 is 8. And then you have another set of electrons around the oxygen because they're both sharing those 4 in the middle. So you have 4, 6, 8 electrons. And then if you count them up, 2, 4, 6, 8, 10, 12, you still have 12 total electrons. And then nitrogen, since each of them have 5 electrons around them, we have to move the electrons to make sure both of them have 8 electrons around their atom, or their structure. So a triple bond, that's 6 electrons, plus those 2 is 8. And the same thing for that nitrogen, because they're sharing 6 electrons between those 2 nitrogen atoms. And if you count them, you have 6, 8, 10 total electrons, so we're abiding by both rules. From counting the total number of electrons and then abiding by the octet or duet rule. So just to practice drawing Lewis dot structures, you have to first identify the structure as either being ionic or covalent. So if you see a metal, like potassium, that is an ionic compound because it's a metal and a nonmetal, you just draw the individual Lewis dot structures. So there's K, and then there's going to be your Br. I'm going to use colored. 1, 2, 3, 4, 5, 6, 7 because it's a group number 7. Then to specify the electron transfer, potassium is always going to lose 1 electron to form that positive 1 charge. Bromine is always going to gain 1 to form that negative 1 charge. So whenever you finish writing out the ionic compound, potassium has lost all electrons, and then the bromine is going to gain all of them. So he'll have 2, 3, 4, 5, 6, 7, 8 electrons around its structure, and then we need to specify its charge in the upper right-hand corner. So this would be the acceptable Lewis dot structure of that ionic compound. Okay, I'm going to erase this, so if you need to write it down, press the pause button, and then finish writing that. Then our next one, BH3. Boron can form either ionic or covalent, but looking at the formula, if boron's in group 3, it forms a -3 charge. Hydrogen can form a -1 on rare occasions, crossing and dropping BH3. So this is an ionic compound with boron. So if boron is in group number 3, it's going to have 3 dots or 3 valence electrons around its structure. So 1, 2, and 3. Then I have 3 hydrogens that each have 1 electron around their structure. So where I'm going to make those bonds, I'm going to make them where there are singlets, because your single electrons, those are going to be your bonding electrons. Okay, so how do I show boron forming a +1 charge? Well, you just specify it with the transfer of electrons. So boron's always going to form a +3, so it's going to lose and it's going to donate its charge, or sorry, its electrons to the hydrogens. So boron will then form a +3 charge, and then you're going to have all the other hydrogens around the structure. I'm just going to put this hydrogen on the other side so I have enough room. Then you write your hydrogens in there. So then now hydrogen is abiding by the that duet rule, because it has those 2, let me make that bigger, 2 electrons around itself. So boron's going to lose those 3 electrons to form the +3, hydrogen's going to gain 1 to form the -1 charge, and then you specify the charges in the upper right-hand corner. So if you need to write this down, press the pause button, because I'm going to do the next ones. H2O and CCl4. Alright, so H2O, 2 nonmetals, hydrogen's a nonmetal, oxygen's a nonmetal, so that's going to be a covalent compound. Well, you can originally start with drawing or writing out the elements separately, and then what you can do is identify their valence electrons originally. So hydrogen's in group number 1, so they're both going to have 1 valence electron. Oxygen is in group number 6, so it's going to have 6 valence electrons. So your single electrons, so if you only have 1 electron, that's where your bonds are going to be formed, because it takes 2 electrons to form a bond. Bonding electrons. So it takes 2 electrons to form a bond. Okay, so then we have to figure out where the bonds are going to be made. So here's a singlet, there's a singlet. So these electrons are going to become close enough to each other to where they can share those electrons, because we need to make sure we have abided by the octet rule, and we have counted the total number of electrons around each of those atoms. But we already did that by writing out the individual valence electrons. Or you could sit there and count. Okay, well, hydrogen is in group number 1, so it's going to have 1 valence electron. But since there's 2 of them, I'm going to have 2 electrons plus the 6 in oxygen, so I should have a total number of 8 electrons in my Lewis dot structure. Or you can individually write out the Lewis dot structures, and then that'll help you figure out its total amount. So then we're just going to draw the sharing of those 2 electrons, since it takes 2 electrons to form a bond, but don't forget to include the lone pairs on the other side of oxygen. So we still have 2, 4, 6, 8 electrons. Oops. Let me undo that one. But if you count or look at the Lewis dot structure, I have 8 electrons around the oxygen, and then I have 2 around the hydrogen because of that duet rule. So this is an acceptable Lewis dot structure of water. And if you need to write that down, please pause it because I'm going to erase it and do the last one. Why is that not erasing? Okay, so our last one is CCl4. I guess that one's not erasing. Okay, so our last one is CCl4. So let's count the total number of electrons. Okay, so carbon is in group 4, so it's going to have 4 valence electrons. And then chlorine is in group 7, but there's 4 of them. So 7 times 4 is 28. 28 plus 4 is 32. So I'm going to have 32 total electrons. Carbon is most likely going to be, or it actually is going to be, the central atom because it has 4 valence electrons for each of the chlorines to come back in and make a bond. They're both nonmetals, so it's going to be a covalent compound. And then I need to show the 7 electrons around my chlorine atom. I gotta make the dots bigger. 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And 2 electrons make a bond, so then you just show the bond formation of the carbon to the chlorine atoms. There's no charges at all whatsoever. And then if you want to go back and count to make sure everything has 8, this chlorine has 8, this chlorine also has 8, that chlorine has 8, and then this chlorine also has 8, and even the carbon in the middle has 8 because the 2 electrons for each bond are surrounding the carbon. And if you count 8 times 4, then that's 32 electrons, so we have abided by all rules. Okay, so have you accomplished the objectives of the unit? If any of this information is unclear to you, please go back and rewatch the video or take notes or highlight questions in your ISN and ask me whenever we go over this lecture.